Hello, everyone. Awesome to be here, and even better to see you all at GopherCon. Are you enjoying it? Yeah. So today we are going to explore the security, or rather insecurity, of JSON Web Tokens. Get ready for a ride. First, a brief introduction. I've been doing professional software development for over 20 years. Yep, sometimes I do feel like a vintage dinosaur. But hey, who doesn't love a classic? I've always been close to code, and that bond still thrives today. However, almost 2 years ago, I joined the dark side of platform engineering at Form 3. And guess what? I absolutely loved it. Today, I'm a lead SRE engineer there. So what do we do at Form 3? In short, Form 3 is a financial cloud. We provide a payment as a platform model for quick and easy integration with payment schemes via REST API. We are technology-oriented, fully remote, cloud-based with microservices architecture. We treat our infrastructure as code almost religiously, terraforming everything possible. Lately, we are building a new multi-cloud payment platform based on Go microservices and free clouds. So obviously, when it comes to payments, security is super important to us. What am I going to talk about today? First, a brief introduction to JSON Web Tokens, just for all of us to be on the same page. The key part of today's talk involves 4 demos that reveal some security problems in the spec, the implementation of tokens libraries, and some problems with our applications. There are a number of caveats related to JSON Web Tokens. And we'll start with the very first difficult thing, which is how to actually pronounce it. And it turns out it's not a piece of cake. As a native Polish speaker, I usually pronounce it JWT in Polish. Yeah, in English, I usually hear the pronunciation as JWT, but I work mostly with non-native speakers, so you know. But as you see, the RFC suggests the same pronunciation as the English word JWT. And it's kind of a wordplay, right? Because JSON Web Tokens, similar to a JWT, they are like brief informal tokens. And the question to you, how do you pronounce it? JWT? Raise your hand. Only a few. JWT? Yeah. Oof, I'm relieved that also native speakers pronounce it like JWT. Okay, I will use this pronunciation during the presentation then. So JSON Web Token is a set of claims that encode usually users' identity and usually users' permissions. It also consists of a digital signature to protect the content against any tampering. It's always handy to take a look at some sort of an example. So we see that a JSON Web Token is a long string consisting mostly of letters and numbers. But when we take a closer look, we can recognize 3 parts separated by dots. These 3 parts are a header, a payload, and a signature. All 3 base 64 URL encoded. When we decode these 3 parts, we see that the header and the payload are just JSON strings. The header contains an algorithm used to generate a signature. In our example, it's HS256, HMAC with SHA-256. The payload contains the actual claims. So in our example, it contains 4 claims: subject, issued at, issuer, and expiration. And the signature is just a binary content. Here we also see the very first problem of JWT, the lack of confidentiality. So the tokens are not encrypted. They are only encoded. So it's easy to decode them and see all data available in claims. So we need to be careful and avoid enclosing any confidential information in those claims. A JSON Web Token is generated on the server side, then it's stored on the client side, usually in some sort. When it's a web browser, usually it's the session storage. Then with each subsequent request, the token is transmitted to the server, usually as part of the authorization header. Then on the server side, the token is verified, and in case of an incorrect token, the request is simply rejected. It sounds kind of simple. So it's time for the reality check. Let's take a look at some security problems of JSON Web Tokens, and let's see some live demos. However, before the first demo, some organizational information. I will kindly ask you for your cooperation during demos. I would like to show a live hijacking of your accounts. So my kind request to you, please go to the demo application. The link is available on the slide, and I will post on my ex-Twitter account. So please register your account, log in, and wait to be hacked. So, oops, yep. I will post the link on my Twitter account. Go for JWT hacking and just register. But please remember, don't use any real data, no real usernames, no real passwords. It could be exposed during hacking. So, oh my God, you are very, very fast. Okay, so we have so many accounts to be hacked. It's difficult to choose one. What shall we do first? Let's take a look at how the authentication in this application works. So yes, we do have JSON Web Token here. And if we copy this JSON Web Token, and if we use this awesome site, JWT.io, I'm sure that you know it, we can see that we have this HS256 algorithm, we have subject and some other claims. Subject basically identifies a user. I'm number 1 because that was the first to register. And yep. So I will perhaps explain a little bit what I'm gonna do in my first demo. So the first demo reveals a problem with the non-algorithm. In JWT spec, there are only 2 mandatory algorithms that must be supported by JWT libraries. The first one is HS256, and the second one is none. What is none? None basically means no algorithm, no signature. In my demo, I will show you how to use the none algorithm to bypass server verification. So let's get back. Ouch, it takes a long time to switch. But we are here. And I've prepared some JSON Web Token before the presentation. And that's JSON Web Token with non-algorithm and subject claim representing number 3. We can take a look at our JWT.io. Yeah, that's subject 3, algorithm none. And how to hack. It's as easy as it looks. We just, sorry, I will log in again. I just need to replace this valid token with this forged one and refresh the page. Wow, thank you, gerbization. Do I pronounce it correctly? Yeah, whatever, you've been hacked. Thank you for your cooperation. So you see, that was pretty simple. So let's take a look what went wrong on the server side here. Why was such a token accepted by the server? So, because we have a vulnerability in our code. And unfortunately, that's a mistake one can make very easily. What's the mistake? At first sight, our verify method looks fine. However, it's not. We've used the parse method, which only decodes the token and does not verify its signature. So in addition to parse, we should also use verify. So it's not maybe it's not like vulnerability per se in the library. However, it's not like the perfect API design when you can make such stupid mistakes easily. And it's not the only library with a none problem. When we search the National Vulnerability Database, we can find many more issues related to JSON Web Tokens. And one of those issues reveals the none problem in another library. That's Java library. And actually, that's a funny story because I used this library in the past, like a couple of years ago. When I was to implement JWT authentication in the Java application, I searched the web, I found some example project, and I copied the code. So yeah, the usual thing we do, copy and paste, right? Fortunately, I was into security for many, many years, so I did some tests. And during pen testing, it showed that the non-algorithm was basically accepted. So since that time, they've improved the API of the library, but it seems that because it was like 5 years ago, something like that. And I was showing this example before, during my Java presentations on JWT. And when I switched to Go and I looked for new vulnerabilities on JWT, it seems that this library still has a problem with its API design. So it's not an easy thing to get. So, and take a look, it was only like a year ago. I've also checked a number of Go libraries, how easy it is to write a piece of code which has some sort of vulnerability or mistake. And fortunately, in the most popular libraries, you are good. They have like good APIs, and it's not possible to generate or implement such a piece of code which allows for non-algorithm, non-explicitly. However, with less popular libraries, you can still have a problem. The one I've used in my demo, Thermo Digital, this one would be like easy to spot. Even though it has like over 900 stars on GitHub repo, it's not maintained anymore. So the last release was like a couple of years ago. So when you are choosing library, keep an eye on the maintenance cycle and activity on the project, right? But that's like common knowledge, I guess. There are three main problems revealed by our first demo. First of all, why the heck do we have none available at all in RFC? I don't understand it. I guess that intent was to use the non-algorithm in a controlled environment like internal networks, but it never works. You have this security in depth paradigm or Swiss cheese security model with different layers of security, so never use none, basically. And never trust client, right? The second problem is misleading APIs, and sometimes also our problem that we do need to read documentation, right? Who likes to read documentation? I'm the only one? Yep. Okay, as you've seen, I'm a little bit lying. I don't read documentation all the time, so it happens for all of us that we do make mistakes, and it's an easy mistake with imperfect API design. So such mistakes happen. To protect our code against such mistakes, we should understand the library in use. We should check out vulnerability databases. And additionally, in our code, we should require some verification, proper implementation of proper verification. What does it mean, proper verification? Basically, we need to make sure that we verify signatures, not only the code, a token, but also perform a check whether this given signature is valid or not. We should verify if whether or not the algorithm provided in a token is the one we use. We should verify and only allow for specific keys, the one we use. Also, one of the most important things, and the one which is very easily missed sometimes, we should check whether or not a token is not expired. And it's a good practice to check any other claims if they match the expected values. So what about the support in our Go libraries? I would recommend for you to go to JWT.io and libraries page. They have a great summary on libraries in many languages, including Go. I've just put on the slide a couple of them, just for you to see what we can look at. And if you take a look at this thermodigital, what's going on? If you take a look at this thermodigital library, it looks pretty good on the paper, right? It supports with this one. It supports like almost all algorithms. It supports verification of all the claims out of the box. So it looks good. However, it's easy to make a mistake with this library. So why to require algorithm and a specific key during verification? Because otherwise we can end up with serious security vulnerabilities in our code. Like this one, when a hacker can trick a vulnerable application to change the algorithm to HMAC SHA instead of RSA. So let's take a look at the attack scenario. For a regular user, the server generates token signed with a server RSA private key, and the server verifies sent token with a server RSA public key. For a hacker, the hacker generates a token signed with a server RSA public key used as an HMAC secret. So if the server doesn't verify the algorithm used, it just uses HMAC algorithm, but it uses the key sent, it uses its public RSA key for verification. And here is another reason why to require a specific algorithm and specific key. It's another vulnerability, and actually the library followed the standard, and that was the root cause of the vulnerability. So that's pretty interesting. Basically, the standard specifies that a JSON Web key representing a public key can be embedded within the header. So that's another problem of the standard, because the main paradigm of cybersecurity is never trust client. Let's move to the second demo. The second demo is a demonstration of a key cracking of H.256. H.256 stands for HMAC with SHA-256. The algorithm is a symmetric algorithm, which means that the same secret key is used for generation and verification of signatures. And so once you get to know a secret key, you can generate your own tokens to be accepted by the server. So let's give it a try. Let's log in again to get this valid token. This time, for our second demo, sorry, I haven't switched to my second desktop. So basically, for password cracking, I will use GPU instances and Hashcat. Hashcat is a free and open source, super fast password cracker. Sorry, I'm so sorry. It's not a password cracker. They call themselves a password recovery tool. Yep. So basically, okay. So basically, I have this token. I will log in to my GPU instance, and I have a hash cat available. Let's see the information about the server here. Basically, we have 6 GPU on the board, or 6 cards, RTX 3090. And I have like a short script to crack the password, and let's take a look how long it takes to crack this password. So basically it takes a long time to initialize all the devices, but once it starts it should be super fast, and we are here. It was like 16 seconds, but on the other hand the password was pretty simple, gopher. So what can we do now? Basically, let's go with our token to our JWT.io site. Once we know the password. Yes, yep. Is it better now? Yep. So basically here I want to switch the subject to 7. That's a lucky number 7. So let's see now. Let's copy the token and let's refresh the page. Hello, you've been hacked. Thank you. So that was our second demo. It went pretty fast because we had really fast GPU cards. However, when I did it on my Mac, it took not so long either for those short passwords. It took like a minute or 2, something like that. So some problems here. Only one token needed. Well, the obvious problem is the weakness of our secret key, right? But another problem is that for the key cracking, hackers need only one token, and all cracking is done offline without any communication to the verification server. So there is no method to detect such brute force attack, and victims remain unaware of attacks. So, and once a hacker knows the secret, they can generate whatever tokens they desire, impersonating whatever users they desire. Also, another problem is like those pretty complicated algorithms. It's like we have plenty to choose from, and sometimes it's too much, right? We are sometimes, as developers, we are lost which algorithm we should use, how to generate a key, and that kind of stuff. I will focus on 2 the most popular families here, HMAC with SHA and RSA with SHA. So as it comes to HMAC with SHA, the recommended key length is as long as the length of the hash. So for HH256 is 256 bits, which means 32 bytes. So it's worthwhile noting that it's a symmetric algorithm. So the shared key is used and present on all the servers that perform verification as well. So when one server is compromised and a shared secret is leaked, then the entire system is compromised immediately. And another popular family is RSA with SHA. The recommended key length here is 2K bits at minimum. However, for security beyond 2030, USDOC recommends 3K bits. So sometimes developers are concerned about usage of asymmetric encryption because it's slower. And the longer the key, the slower the verification process. However, with today's modern hardware, it's not much of a problem. So I think that it's good to improve our security and our performance shouldn't suffer so much. Let's take a look at our third demo. Basically, I will use packet sniffing. I will steal one of your tokens by packet sniffing. So let me log in. So I don't need my GPU instance, but I need my Oracle instance. Basically, that's the same server. So, usually for this kind of stuff is one thing is to use HTTPS from a browser to the server side, and we do use HTTPS here. When you take a look at the example application, it's secured. However, many developers think about internal networks as like protected environments. And it's not always the case. Many attacks are performed by insiders. So here you can think that I'm inside our internal network and I'm doing like running TCP dump. So I have a kind request to you. Please refresh your pages. Okay, a lot of traffic going through. Thank you. I need to stop and I need to search for better for this header. Okay, so, and again, it's like a one-trick pony. We will copy the token and replace the valid token with this one. And that's you, cherbization. Let's find another token then. Don't be so greedy and let others to be hacked. Yes, Hacker 101. Yeah, basically that's like 101 in hacking. That's right. Thank you. Hacker, you've been hacked. So, as you can see, the problem is that stolen tokens can be freely used as long as they are valid. So, and obviously you see that if you have any lag of transit unencrypted, you have a vulnerability, basically. That's a risk. Obviously, it's about risk management, and if you accept this risk and you are aware of it, that's fine, that's on you. However, many times we are not aware about the risks, so it's always good to take a look at our infrastructure and deployment practices and protect any lags of transit over which we send confidential information. So now the time for our last demo. Well, one more thing about the previous demo. The problem was that the transit from a browser to the server was encrypted. However, from a load balancer to the application server was not encrypted. So it was internal network. Let's think about the situation when we have our entire transit properly secured, everything's encrypted, and still I'll be able to hijack your sessions. This time by exploiting an XSS vulnerability to steal one of your tokens. So let's move to the application again. I will relog as Patrycja. I don't need DevTools anymore here. Here you see that you can configure your web page. And such fields usually are prone to any injection attacks. And XSS cross-site scripting is kind of an injection here. So I will update my supposed web page, and you can see that there is a link now. And wait a moment. This time I will log into my evil server. Yep, and I will observe logs to see the stolen tokens coming. So basically I have again kind request to you. Please click this link. It looks like okay, right? That's in application. And we see a lot of tokens coming. Thank you. Super nice of you. And let's copy one of it. Let's switch to DevTools again. And again, replace the token. Who is lucky this time? I'm not gonna pronounce it, but thank you for your cooperation. You've been hacked. So just time for some summary. Let's take a look at our XSS attack vector here. So nothing tricky here. The only tricky part is that the malicious JavaScript is that we do not connect to our evil server directly, but we connect via loading the link as an image source. This way we bypass same origin policy. Other than that, it's a simple JavaScript, right? We just getting session storage, get item token, and sending it to our evil server. Obviously, the problem here is that we have an XSS vulnerability in our application, so we should apply our anti-XSS practices. There is no other way to block access to a session storage for JavaScript, unfortunately. So when you want to use JSON Web Tokens, usually it's better to go for a cookie as a storage mechanism. Because with hardened cookies, we can use some extra flags like secure HTTP only, same site, to protect cookies. With session storage with JavaScript, we can do nothing. So it's good to use like hardened cookies as a storage mechanism for JWTs. But this way we have another problem. It's like cross-site request forgery, but that's for another presentation. Also, it might be worthwhile to take a look at token sidejacking solution presented by OWASP, but frankly speaking, I haven't seen this one to be used very widely, but it might be good like brain exercise, just to go over it and understand the logic behind it, because it uses both cookies and headers together in a very special way. And this is only the tip of an iceberg here. Because in addition to algorithm implementation, protecting against eavesdropping, XSS, etc., we should consider logouts and timeouts as some kind of basic hygiene for our safely designed applications. And unfortunately, JWTs do not provide any built-in feature to revoke a token or expire a token after inactivity period. So think about like basic principle. We need to provide a logout feature in our application, right? Logging out and cleaning like session storage is not enough. Why? Because this token is still valid until it expires. So we need some way on the server side to mark our tokens as logged out, like invalidated. And so JWTs are advertised as a stateless session mechanism, and here the state strikes back. Because again, we need some sort of a storage on the server side for invalidated tokens. So again, a lot of things on us, poor developers, to do correctly. Remember, a fool with a tool is only a fool. So we can't be fools. We need to know and use our tools wisely. In software development, there is that continuous integration paradigm, continuous delivery paradigm. We often talk about continuous refactoring, but the fundamental paradigm is continuous learning. As developers, we must keep learning, and that's what conferences are about, right? So thank you for your cooperation today. It was a pleasure to hack you. Thank you.